Hello, welcome everyone. This is Dhimande Goswami and welcome back to my channel. So today we have a very nice problem in front of us. So let's start with it then. So it says that a wire of length 2 units is cut into two parts, which are bent respectively to form a square of side x units and a circle of radius r units. If the sum of the areas of the square and the circle so formed is minimum, then so we have to find one of the options out of these. So if you want to take, when I attempt it for some time, then just pause the video and just try it for yourself. Otherwise, let's delve right into it. So mainly, if let's say this is a 2-unit wire, so we'll cut it into two parts. Let's say this is part 1, this is part 2. So the first part will be made into a square and the second part will be made into a circle. So the first one's side is x units and the second figure's radius is r. All right. And perimeter of the first one plus perimeter of the second one combined together gives us 2 units. All right. So that should be understood and clear. So perimeter of the first one is nothing but 4x. And perimeter of the second figure is nothing but 2 pi r. This is circumference of the circle, right? So this is equals to 2 units. All right. So from this, what do we get? We get x plus pi r equals to 1. So 2x plus pi r equals to 1. So this is our equation. Now, what we are asked here is we are asked to find the area of the sum of the both figures. So area of both these figures will be nothing but pi r square plus x square, right? X square being the area of square and pi r square being the area of circle. So we need to minimize this area. So we'll be using the concept of differentiation, but we have two variables here. So that's the reason why we need to find the relation between r and x, which we will get from this equation, this one. So let's convert it in that form then. So from this, what do we understand? Let's convert x in terms of r. So what do we get? 2x equals to 1 minus pi r. So therefore, x will be equals to 1 minus pi r by 2. So this is going to be our x value. So that we will substitute there. We are going to substitute it in our area formula. So our total area of both the figure will convert to pi times r square. Wait, pi times r square plus x we have got 1 minus pi r by 2 whole square. So this gives us area to be as pi r square plus 1 minus pi r square is nothing but, so we take 1 by 4 outside, and 1 minus pi r square will give us 1 plus pi square r square minus 2 pi r. So this will be the value. All right. So this, if we simplify it further ahead, we get pi r square plus 1 by 4 plus pi square r square minus 2 pi r. So pi r square by 4 and 2 pi r by 4. All right. So if we need to minimize it, so we need to do dA by dx. So dA by dx is nothing but what do we, okay, dA by dr in this case, since we have r as our variable, so dA by dr we will get 2 pi r plus 1 by 4 will become 0. Next we'll have pi square by 4 into 2r and minus pi by 2. Since in this case 2 and 4 gets cancelled, this is 2. So pi by 2 will remain, r will be out. So this is our value then, right? 2 pi r plus pi square So we simplified it a little bit ahead. So 2 pi r plus pi square by 2r minus pi by 2. Now this must be equal to 0. We need to equate this to 0, dA by dr to 0 for to find its minima or maximum. So for that, what we will find ahead, if we do that, we can say, let's take it further ahead. So let me quickly try and find a solution for this one. So from this, we can take 2 as our common denominator, and we get on top, we will get 4 pi r plus pi square r minus pi equals to 0. So let me use the left hand side of the sheet. So from there, what do we get? So we get 4 pi r plus pi square r minus pi equals to 0, taking 2 to the other side. Similarly, we can also take pi out, pi common, right? So from that, we can also say pi r, 4r plus pi r minus 1 equals to 0. All right. So from this, we can say that if we take r common, 4 plus r equals to 1. So this will give us r equals to 1 by 4 plus r. So if r is 1 by 4, if okay, so 1 by, this will be 4 plus pi. So this is 4 plus pi. So r will become 1 by 4 plus pi. Now to make sure that this is the minima, so we need to again double differentiate dA by dr square. So if we do that, what do we get? We get that this only there is one negative part here. All right. So this negative part is just a constant. So therefore, the rest of the part is always going to be positive since r is always positive, right? And all the numbers are positive here. So you can directly say that d square a by dr square is greater than the second derivative of a with respect to r is greater than 0. That means you will always get for any value of r, if it is 0, like this one, double differentiation is greater than 0, and at r equals to 1 by 4 plus pi, you get this first derivative as 0. That means it is a minima. So for this value of r, we get this as minima. So now if we plug this in this equation, we get x as equals to 2 by 4 plus pi. And we know that 1 by 4 plus pi is r. So therefore x becomes 2r, and therefore our answer is 2. I hope you understand the problem easily. If you need any more further guidance, then I have, put my Telegram link in the description. Do like and subscribe the channel. If you have any doubts, you can contact me in the Telegram group as well. Thank you so much.